Hello guys and welcome to this recitation on the fundamentals of Numpy. This is the last part of this recitation, and in the previous recitations we covered the basics of what you need to do most of your Numpy operations in the deep learning class. But we also saw the notion of broadcasting, where Numpy automatically broadcasts the dimension of your array to the kind of operation that you want to complete. So through this operation, there are a couple of issues that you can face if you don't have a real, you do not really put time to look at the shape of the data you are manipulating. Here, we'll try to look at some of these issues and how we can solve it. So let's get started. The first thing that we want to see here is the element-wise multiplication. So suppose that you're working with 1D and 2D arrays in NumPy. Some of the issues that I'm talking about can arise, and how do we solve it? If you are doing element-wise multiplication of a column vector with the shape of A1, for instance, and a row vector with the shape of 1A in NumPy, the result will basically give you a 2D matrix with the dimension A and A, and this is not a vector. So this is kind of issue that can occur when you are doing operation using NumPy, because NumPy will automatically or implicitly do the broadcasting operation for both the 2D, for both vectors for you to get the 2D matrices when you are doing the operation. So this same behavior can also occur if the second input is, for instance, a 1D array of shape A instead of a row vector. So NumPy just treat it automatically like 1D array. So it will treat the 1D array as a row vector, sorry, during the operation, which will lead to the same outcome. So this the operation works only when both vectors are of the same shape. So they are either columns or rows vector of 1D arrays. So this will consistently do the operation of broadcasting. So let's first try to create some arrays and try to see how this operation will work. So here we create an array of one dimension, of dimension 4. We create a second one here as well with the same dimension, and we create a third array here with the which is a 2-dimension array of dimension 4 of size 1. So we'll look into some case of operation that we can do with it. If we are performing an element-wise multiplication on both arrays, so basically the element-wise multiplication here will be using the normal multiplication sign to do your operation. So this will try to match each entry from one array to the other one when they are doing the multiplication. So the operation that we know that both the column vector that we are using here and the array here are of like different shape. So what it will do is that this will automatically do the broadcasting and create a 4x4 matrices as a result from what we know. So if our goal is to get uh, the matrix multiplication, so what we do, we use the @ operator here. And then when we use that operator, this will automatically perform the matrix multiplication and get the scalar value for us as a result, because these are two vectors. So when we do the matrix multiplication, the output should be a scalar. Another thing is if we do the element-wise addition of both the two arrays that we created, since that they are of the same dimension, this will just do the addition entry by entries and get us an array as a result, which is here. So another case of situation is if we do the element-wise addition now of the array, which one is column vector and the other one is a row vector, this will automatically do the broadcasting operation for us. So implicitly, the broadcasting operation will be done, and we get a 4x4 matrix. That's why we say that you need to really check the shape of the matrices or maybe the arrays that you're manipulating before you do any kind of operation, because NumPy will implicitly hold the broadcasting operation for you. If we want to do matrix multiplication, so we can just like use the @ operator for what we want to do. So we consider a scenario where we suppose that we want to perform a matrix multiplication, but sometimes we can by mistake use the asterisk instead of the matrix multiplication operator. So this is some of the issue that you can face, and we'll see how we can cover some of the issues related to that. So let's suppose that here we have a 4x4 matrix, which is a 2-dimension array that we created here. We generated the entries randomly, and we will look at some other issues that we can face with it. So basically, the matrix multiplication, which involve 1D array, will act as a row. The 1D array in that operation will act as a row vector and a 2D array. So if we try to do the multiplication, the result will typically give us a vector which is correct. But if we try to use the element-wise multiplication, this will automatically handle the broadcasting operation for us and do the multiplication, because this will be done entry by entries as I stated before. So these are some of the issues that you need to look at. So you need to clearly know what kind of multiplication you are doing, whether it is matrix multiplication or element-wise multiplication operation, so that you know when the broadcasting will automatically happen. So the same thing can happen when you are using PyTorch. So you will similarly get the same kind of issue using PyTorch, because in this class, you will use both NumPy and PyTorch during your work. So suppose that we create a 1D tensor using PyTorch here. So the size is, for instance, 4, and we create another tensor of size 4x4. When you perform the matrix multiplication, this is automatically handled and your operation will work by using the appropriate dimension here. But if you substitute the @ operator to do the element-wise multiplication, this will also automatically do the broadcasting and compute the operation for you. So you will need at anytime you want to do a multiplication between different arrays or maybe tensors, you will need to check what kind of operation you want to do, whether it's element-wise operation or a matrix multiplication using the @ operator. So depending on the kind of operation you want to do, you need to check. If it is element-wise, you need to check the shape if you do not want to get the automatic broadcasting operation in your work. So this takes us to the end of our recitation on the fundamentals of NumPy. And if you want to get more, see how some of the functions or maybe methods available in the different package works, we can also take a look at the documentation and practice more. Thank you for watching, and see you in the next.